Okay, so for this problem, we have a 2 kilogram mass on a frictionless ramp angled up at 20 degrees with respect to the horizontal. And the question is, what mass, little m, should be hanging from the other end of the string that goes over the pulley so that everything's in equilibrium and there's no acceleration of big M nor, therefore, of little m. And again, this will be frictionless, so I'm going to assume u equals 0 here. So in order to do that, I've got my standard coordinate system for a ramp where I have the y pointing upwards perpendicularly but away from the ramp, and the x direction pointing parallel to the ramp and up the ramp. And so I have a free body diagram for big M here and for little m over here. Let's look at the one for big M first. So the big M has 4 forces on it, 2 vertical forces. It's let me back up for a second here. There's 3 forces acting on big M. The tension of the string, the normal force of the plane that's acting perpendicular to the plane, and the weight, mg. And so I am going to take this mg, downward mg, which is the weight, and I'm going to break it up into mg cosine theta. This angle right here is theta. And mg sine theta. Mg cosine theta is going to cancel the n. Everything has to be 0 here because there's no acceleration in any direction. And the mg sine theta has to cancel the t. So that's what these two equations say. Going over to the little mass, little m, the same tension that pulls the big M up the plane is acting vertically upwards on little m, and this now is the downward weight of little m, and so the tension in the string has to be equal to the weight of the little m. So if these two equations are true, I can set mg, little mg, equal to big mg sine theta, just basically setting them equal to each other. You can see if I do that the g's on both sides cancel out, and I conclude that little m can be determined by big M times sine theta. And so big M in this problem is 2 kilograms. And the angle theta is 20 degrees. And so 2 kilograms times the sine of 20 is 0.68 to 2 decimal places here, kilograms. What would happen to the value required to make this be in equilibrium for little m if the angle here was increased? Would a larger value for the hanging mass be required, or a smaller one?